Now for part 11. Welcome back, ladies and gentlemen. In this video, looking at the input-output reversal property. First a proof, then an example. Begins with a definition of the inverse function. Says, a function f from set A to set B, denoted a function f, A returns B, is invertible if there exists a unique function g from set B to set A, denoted a function g, b returns a, such that. In notation, which is why we did a video on composition of functions, g circle f of x equals g of f of x equals x. For all x in A, we also have f circle g of y. To unpack that, we can consider the inner function of g is f of x, or the output of f. See that? Although there's a duality happening because f of x is the output of f and the input of g. But then the notation helps to clarify, which conveys we have g of b, which returns a. So x is the output of g and the input of f. Next, the inner function of f circle g, g of y, or the output of g. See that? Although there's another duality happening because g of y is the output of g and the input of f. But then the notation helps to clarify, which conveys we actually have f of a, which returns b. So y is the output of f and the input of g. Thus, the function g is called the inverse of f, denoted in the blue box, read as f inverse. In simpler terms, f inverse undoes the operation of the original function f by swapping their input-output roles. Let's do a proof. All we want to do, show the white box, which is the relationship y equals f of x is equivalent to the relationship x equals f inverse of y. Sound good? If so, start by letting f, where set A maps to set B, be an invertible function, and let y be an output in B corresponding to an input x in A, so that y equals f of x. Essentially, everything we just said compacted into one statement. Next, apply the inverse function to both sides of y equals f of x to get f inverse of y equals f inverse of f of x. Observe the first blue bullet, g of f of x equals x. If g equals f inverse, then consider the third orange bullet. We apply the definition of the inverse function. We get f inverse of f of x equals x for all x in the domain of f. The final equation, last orange bullet, white box, shows the inverse function f inverse takes the output y of the original function as its input and returns the original input x as its output. The roles of input and output are thus reversed. We are done. Nice. So invertibility relies on the inverse function reverses the roles of the input and output of the original function. Let's do an example, see it in action. We actually have an interesting function. F of x equals 9 over 5x plus 32. Has anyone seen this? A function that converts temperature in Celsius to Fahrenheit, where x is the input in Celsius and f of x is the output in Fahrenheit. Letting x equals 20, considering c as a constant, then we have 20 degrees in Celsius. Third orange bullet. Let's find f of 20. We have 36 plus 32, which just equals 68. That sounds about right. What do you think? Last bullet returns the following input-output pair 20, and 68. According to the said property, if we take the inverse of f of x, process will return the pair 68 and 20. Let's see if that's true. Orange asterisk are the details from the previous blackboard. So, what is f inverse? We have f inverse of x equals 5/9 times x minus 32. So how did we get that? Second orange bullet. To find the inverse of f of x, replace x with y, then solve for y. Then subtract 32 from both sides. Last bullet. Times each side by 5/9, which returns y equals 5/9 times x minus 32. First orange bullet. We can rewrite the inverse of f, the blue box, read as f inverse of x equals the following expression. Basically, the relationship in the blue box is equivalent to the white box because f of x equals y in the white box, whereas f inverse of x equals y in the blue box. Nice, because next bullet we can define the inverse g as degrees in Fahrenheit returns degrees in Celsius. Then let's find f inverse of 68, which equals 5/9 times 36, which just equals 20. Last bullet, folks, returns the input-output pair 68 and 20 red box, which shows a clear demonstration of the input-output reversal property.